Welcome. This is Mrs. Azrak, and this is the Proximity Game Screencast mini lesson. There are two parts to this lesson. Between the two parts, I will be asking you to pause the screencast, play the game Proximity a number of times, and then come back and resume for part two of the screencast. So let's get started by opening an internet browser window. Type the web address that is located on the first page of your handout. It is http://ccsgames.com. This takes us to the Data Games website, and we'll be playing Proximity, which is the game in the middle, so click on its purple play button. We're taken to a login screen, but we're not going to put a user and password. Instead, we're going to click on the gray button that says Login as Guest. The Proximity game has three main screens. There's the main game board, there's a graph, and there's a table. The object of the game is to get the ball as close as possible to the middle of the target by pushing it. To push the ball, you must click on the ball, hold the mouse button down, drag away from the target, and release the ball by releasing the mouse button. Notice when I click on the ball and pull back, a number appears. This is the magnitude of my push. You get 6 targets per game, and you're trying to get the highest score possible. If you pull back very hard, the ball is likely to bounce off the walls. Now, using the graph, you should be able to answer the first 2 questions in your handout on page 5. What type of correlation is there between distance and push? We've already studied correlations, so this should be pretty easy for you to answer. The second question, what could be a good representation for this data, is a little tricky because of the ball that bounced off the wall, but this data still has a good trend to it. I think you'll be able to make a decision on what model to use for this data. Notice also that the table provides the numbers for the push and the numbers for the distance that the ball ended up from where it started. This can also help with the prediction. By clicking the ruler to make a measurement, if you click on the ruler and then click on the middle of the target, drag to the center of the ball, you will get the distance of 103 units between the target and the ball. With that information, you can make a better prediction of the push. Now I scored 295 points on this first level dock. If I click on the levels button, I see the next levels. At Sneezy, I need 500 points on dock to open it. For Dopey, I need 425 points on Sneezy 2 times in a row. That's our goal for today. We're going to try to open the Dopey level. For now, click on the X to close this box, and click on the New Game button to start a new game. You're almost ready to start. There's one more thing that you have to do. As you play each game, you'll need to fill in your scorecard. So here, for the first game, I was on the dock level, and I got a score of 295. Now hit the pause and start to play the Proximity game. Don't forget to record your results. And after you've played the game 3 times, come back to the next part of the screencast. Did you make it to the Sneezy level? The representations should have helped to make the push prediction. But if you still didn't open the Sneezy level, don't despair. The algebraic representation can help determine the push prediction. To get a line and an algebraic representation on the graph, click on the gear in the upper right-hand corner. Pull down to the second item that says Show Movable Line. The line will appear. You can click on the line and drag it, and the algebraic equation will change accordingly. Place the line as best you can to fit the data. My equation is the distance equals 9.79 times the push plus 4.9. Do you recognize this algebraic form? It's the slope-intercept form that we've been using for linear equation. The y equals mx plus b, where m is the slope and b is the y-intercept. The slope of 9.79 can be used to make a prediction. You can use the ruler, click between the target and the ball to get the distance of 131 feet. This is the y value. We can divide the distance by the slope to make a prediction for the push. Now to do this calculation, you might need the help of a calculator. So in the toolbar, if you click on the icon that says Calc, the calculator appears. Type in 133 divided by the slope of 9.79, and you get an estimated push of 13.5. Now that you have the equation of the line, you can play proximity some more and hopefully improve your score. Use the scorecard in part 2 of your handout. So in the part 2 scorecard, you're going to fill out the level doc. My score this time was a 574. My equation was 9.79 plus 4.x plus 4.9. So my slope is 9.79 and my intercept is 4.9. Did I open the next level? Yes, I did. Each level will have a unique line, so fill the table in for each game as you play. Continue to play the games until you have at least opened the dopey level. If you make it to the grumpy level and answer all your questions before the end of the class period, you can have the game verified and get 10 extra bonus points. If you get frustrated, check the mini lesson blog. I will provide you with a few extra cues there to help you along. Remember, your homework for tonight, besides trying to get to the dopey level, is really to complete the questions at the end of the packet. Come prepared tomorrow to discuss your approaches that you used in class today. This is Mrs. A, and I hope you have a great, fun-filled learning day.